Okay guys, you have done a post process on Inventor HSM, and now you have your G-code, that .nc file, and you're ready to take it to the mill. So first, with the defragulator, we would just use this IntelliTech CNC Motion to virtually check it out. And if we wanted to mill it out for real, then physically after we've verified it here, then we could take it and run the real piece. Okay, so this simulates what you're actually going to do on the machine, and kind of just make sure everything looks right, that actually came over from Inventor correctly when we post-processed, and you know, basically it's going to be very similar to what you do on the real machine. So, alright, so first off, if you just open the machine, you may have to home it. Now I believe it's in the home position for me, so I'm going to just jog the machine a little bit down and kind of over, just so it's not in the home position, so you see it do something. If you home the machine when you first open it and you don't see it move, it probably is already in the position. Let me zoom out a little bit too. Alright, also make sure you know that the shield has to be closed in order for it to move. So right here you've got your shield opener and closer. So I'm going to close the shield, and then under setup here I can go to set or check home. Also you can use Control H, and you can hit the home button, and it's now going to move. And I've got it, you could do quick home and it'll just kind of snap there, and that just moves it back into the home position, so it reaches its limits for the X, Y, and Z axis. Okay, the next thing we're going to do is make sure that the stock is the right size. Okay, under 3D image you're going to go to setup machine, and this is where you can check set the stock material size. And for the defragulator, it was supposed to be a 3-inch by 2-inch by 2-inch block. It was Ren material. I'm leaving this set to plastic. Okay. In the verify window over here, we also want to make sure this is set up correct. And let's see, under setup, you can go to verify settings, because if the last thing you did on here was the yo-yo, by chance this you know, the bit here is not going to be at the corner. It might be in the middle, or who knows. So rechecking these things. Alright, so I'm going to go to stock in the verify settings, and I'm going to also set the dimensions to be correct, 3 by 2 by 2. And the origin is going to be, our stock origin here is going to be this corner. It's going to be 0, 0, 0. And the initial tool position we want to be there at 0, 0, 0. So we're going to set all that. Now the machine needs to know where that corner is. Where is 0, 0, 0? Okay, so I can manually jog the machine over and down, and virtually this is a little difficult at times to really zoom in and get it exactly right and not crash into the machine. So we do have a shortcut here, and that is this send tool to corner. So we're going to go ahead and use that and just send the tool to this front top left corner. Okay, and once we're there, we want to set that position to be 0, 0, 0. Now mine's already there, but if it weren't, you would go to setup, and we would say set axis to 0. Okay, and then this is similar to the machine, how then you can say, okay, I want it with the current position, I want the x-axis to be 0. And then you can go through and do that for each one. Set axis to 0, and you can go, yep, you know, if you're doing them one at a time, now the position I'm in, I want this to be the 0 for the y-axis, etc. So you repeat that for all three. In CNC Motion, let's see, if I just did set position, I can set all three at the same time. Yeah, there's kind of a shortcut that we don't have on our Linux machine. Okay, so I've got the stock size, I've got the machine zeroed at the correct corner, I've got the verify window set up. I haven't opened my program yet, so now let's open our program. Open, go to my desktop. It's easier for me to find this in detail lists and just to sort by the date modified. Okay, and here we go. It's condensed here, but I see defragulator example. Okay. Now, here's something really important. When I did my at least this is really important for getting it to work in CNC Motion. With our mill, it'll be a little easier. The tool that is defined in the program is actually going to load in. On our machine, you physically could have the wrong tool in, or a different tool than what's in the program, and the machine doesn't know. It's just going to run the path. Well, here the machine's going to auto put in the tool, and we need to make sure that the tool in the program matches the tool in Inventor. So I can see that the 2D pocket here started with tool 3, which is supposed to be a 1/4 inch end mill in this program. And if you go back to Inventor, I'll bring it up for a second. Okay, you can see that I had tool 3 for the 2D pocket, tool 3 for the drilling, and that tool 3 was a 1/4 inch flat end mill. Okay, to mill out that was a 1/4 inch hole. Then we switched to tool 1 for the slot, and that was a 1/8 inch end mill. Inside CNC Motion, if I go to Tools and to set up the library, I have all these tool positions, and these tool positions need to match. And so you can go in and create all the tools, pull up both the Inventor tool library and this one, and go through and place them all in there. If you want, you don't need to take the time to do all of them. We only needed tool 1 and tool 3. But I need, in this tool library, I need tool 1 to match the tool 1 that has been programmed. Okay, so we started with, this program is going to start with tool 3, which is the 1/4 inch end mill. So let's check that, tool 3 first. Yep, is the 1/4 inch end mill. Now I had preset this up just a few minutes ago, which is why this is all correct. And then we're going to switch to tool 1 for the last path. That's for that slot, and that's supposed to be a 1/8 inch end mill. So I've come in here and I've chosen the tool type. I've made a descriptive name. I've set the correct diameter for us and for verifying the number of teeth, and material type's really not that big of a deal. But they are carbide tipped bits that we have, and the number of teeth is 2. So if you want to get that correct, so make sure your tool library is set up. Okay, at that point you should be ready to run. The tools match, the program's here. Okay, in CNC Motion we can run it in 2 different ways. We can first verify using this verify window. Okay, in the verify window you do have a reset button right here, and then up here we have the verify. So I'll try pressing that. Brings up the program. Say yes, we want to verify it, and it prompts us for the tool change. Insert tool 3. This is where it gives you time to manually make the change. Okay, press F5 to start. It should have the 1/4 inch flat end mill, and this is obviously going at a faster speed. And then it did the second operation we had, which was the drilling operation with the same tool. At the end of that, it's supposed to go to the slot, which has been prompted for a new tool. So it's paused, giving us a chance to insert the new tool, the 1/8 inch mill. Okay, should be in. CNC Motion does it automatically. Press F5. There you go. So this is a way to quickly mill that out. You can increase the speed at which it verifies using the plus and minus button. And if you want it to run in real time, now on the virtual mill right here, we can use the play button instead of the verify button. I'll go ahead and reset the verify window as well, as that will run at the same time. So let's hit play, run the program, insert the tool, press F5, and now it's going to run. Okay, so we've just walked you through how to post-process and how to reset up CNC Motion. Okay, remember the key steps in CNC Motion were homing the machine, setting the stock size, getting the correct work origin here at the corner to be 0, 0, 0, getting the tool library set up so that the tool that's in our code actually matches the tools that are programmed in here. Then you can verify in just the verification window, and you can run the program. Okay? Good luck, and hopefully it all works out well for you.